Hi guys, welcome back to my YouTube channel, and today we'll be doing some more work on hidden quadratics because I think it's quite an important skill and people like overlook this because it does help in lots of other parts of all the maths you'll learn in year 2. So let's just do some examples that I found. So first one, x to the 4 minus 3x squared minus 4 is equal to 0. So this first one is just a simple one. This is just a substitution y equals x squared, because you can see every term is double what it should be. The x terms are double what they should be in a normal quadratic. So if I use the substitution, I get y squared minus 3y minus 4 equals 0. Then y minus 4 and y plus 1, because you need to add to make minus 3 times to make minus 4. So then our solutions would be y minus 4 equals 0, so y equals 4. And then we have y plus 1 equals 0, so y equals minus 1. There we go. Okay, next question. We have, this is a bit of a trickier one. 2x plus 3 equals x to the half. So it's a bit trickier to see because there's no 4 and 2, but like normally they could write it like this as well. So if they write it like this, you would have to convert it into indice form because it's always easier to see hidden quadratics in indice form. So if we have this, what we can do from here is that we notice that the x terms, we have an x and an x to the half. So whenever you're finding the answers to disguised quadratics, all you want to look for is a pattern. Is one power half of the other? So here we have 4 and 2. So this is half of the other, so it's a disguised quadratic. This one, we have an x and an x to the half. The x is actually just x to the 1, and we have x to the half. So is one half of the other? Yes, half is a half of 1. So therefore, this is also a disguised quadratic. We can substitute, let's just use t. T is equal to x to the half. You always make your variable the smaller one, so x to the half in this case. So then we would have 2t squared plus 3 is equal to 7t. So then if I just move that to the other side, 2t squared minus 7t plus 3 equals 0. Then we have 2t minus 1 and t minus 3. Because it's a bit hard to see, but we would have 2 and 1, 2t and t, because that's the only thing that makes 2t squared. And then minus 1 and minus 3 because they make 3. And this becomes minus 6t, and this makes it a minus 7t. So yeah, okay. Next, so now we can just solve this. So t would equal to t would equal to a half, or t would equal to 3. Oh yeah, and one more thing I forgot for this first one. We found y, but we never found x. Here x would be plus or minus 2. Here x would be nothing because you can't have a square root of a negative number. And here our t was x to the half, so we're saying root x is a half. So then x squared both sides is a quarter. And over here, root x is 3, so x would be 9. Sorry, this is t. Oh no, this is x. There we go. Okay, let's do another one. Here we have t to the quarter and plus 2t to the minus a quarter is equal to 3. So we have this. Now you'll probably say, oh, a quarter is not a half of minus a quarter, or a minus quarter isn't a half of quarter, so this isn't disguised quadratic. Well, there is another rule. If they are the same distance away, so if you have 0, if they are the same distance away, So we have 0, a quarter is a quarter to the right, and minus a quarter is a quarter to the left. So the distance between them is a quarter, which means we can make y equal to t to the quarter. And that would allow us to have y squared plus 2 over y equals 3. Because, just y. And then we can just multiply by y to get a quadratic. So either they are half to the left, half to the right, or they are half of each other, or they are half left, half to the right. So here we can just do some rearranging. And our quadratic, we'd have 2 and 1, and then be minus 2 and minus 1. So y equals 2, and y would equal to 1. Now we have to actually find what t is, because that's what we started with, and our substitution was t to the quarter. So we would have to do it to the power of 4 to get rid of the quarter, because if we times both sides to the power of 4, the 4 and the quarter cancel out, so we get t equal to 16. And over here, our t to the quarter was 1. So then our t 1 to the power of 4 is just 1. So those are solutions for t. But yeah, that was just some disguised quadratics. I feel like the only way to get good at this is just practice. Like if you do enough questions, eventually you'll see yourself that you'll be like, oh, is this an disguised quadratic? It'll just kind of stick to your head as one of the things you like subconsciously just kind of check in your brain if this could be a way to solve a problem or not. But yeah, okay, that was it for this video. I really appreciate if you like and subscribe, and I will see you guys in the next video. Bye.